Good afternoon and welcome to our Progress webinar, Eliminating Data Silos for Mission Success with Semantics. Joining me today is Senior Account Manager Stephen Reed and Senior Sales Engineering Manager Steve Ingram, both from our Progress Semaphore team, so experts in metadata management and knowledge models. So looking forward to speaking with them today. Today we're going to be talking about modernizing the infrastructure that you have in your business and looking at semantics and new tools that can help you sort out the underlying data environment that you exist in. You know, while 91% of state and local agency leaders agree that with their agency will benefit from modernizing IT infrastructure, only 40% say it's a priority today. That's from EY's Federal, State and Local Trends report from this year. So interesting to see there seems to be that gap in, acknowledging that they need to modernize that infrastructure, but not really the big priorities. So, but public sector data today, as a part of that IT infrastructure, is scattered. It's siloed. It's isolated. Sometimes for use case dependent reasons, but sometimes for legacy reasons as well. These data silos create new challenges. They inhibit productivity, decrease the data quality in the organization, and impact proper analysis. 94% say their agency has concrete plans to invest or enhance technology in the next 5 years, which is great to see because as we know, data is becoming more and more important today with the rise of AI and other data-powered tools. This topic becomes kind of front and center for many organizations and agencies. And so what we're going to talk about today is really breaking down those silos for a better working world, increasing your organizational efficiency, improving data management and insights, enhancing organizations' ability to use data, free up your employees' time for more valuable work, and reduce operational costs. And we've seen that in customers that have adopted our technology before in the past. And I know that Stephen and Steve are going to give you some really good examples today of how the technology can help you in these areas. If you have any questions for our panelists today, please do raise them. There should be a bar on the right-hand side of your screen. The little hand. Raise your hand, type in your question, and we'll get through to as many of those during our live Q&A session at the end of this event. If we can't get to you, then we'll make sure that we'll connect you with Stephen, or one of our other Semaphore experts or Progress experts in our business to answer your question. So with that, I'll hand over to Stephen. Stephen, it's over to you.
Well, thank you, Philip. I appreciate that introduction. Again, my name is Stephen Reed. I'm here, Senior Account Manager here at Progress Semaphore. Just to kind of recap today's agenda, here are the main items we're going to be talking about. One, we're going to be talking a little bit about why data silos exist and the barriers they create, and also signs that you may have them within your organization. And then we're going to start talking a little bit about how semantics can bridge those data silos gaps and techniques for being able to do that. And then we're going to look at 4 specific public sector use cases. Each is going to highlight a different application and how we can use semantics to break down those data silos. Then we'll just transition over to Steve Ingram for a demonstration, and then we'll wrap up with some Q&A. So when I was thinking about preparing for this presentation, one of the thoughts that went through my head is like, gee, I wonder how long we've been dealing with this data silo problem, and has it been getting better or worse over time? So I started doing a little research. If you haven't played around with the Google Ngram Viewer, I suggest taking a look at it. You can put in any type of word or phrase, and Google will tell you basically the usage of that word over time. So I started with, well, I wonder where the use of just information technology, and it's interesting, we're actually starting to dip off in the usage of that word choice over time. But more interestingly, I found that data silo is actually increasing in usage over time. So that would lead me to believe that we still have very much of a data silo problem because we haven't quite seemed to figure out how to crack that nut. which would beg the question, well, why do data silos exist at all? Why are we still seeing so many of them causing problems with the challenges that we have with our data? And I think some of the reasons are fairly obvious. One, just the fact that we have multiple data repositories, we probably have different vocabularies associated with them. That one's fairly straightforward. But I think there's also some other subtle reasons of why data silos exist well. One is some applications want their data presented in a certain way. So the classic way for solving that problem is typically through an ETL function. I make a copy of my data, I perform some function on it, and I make a copy of it someplace else. And I also, by doing that, I have yet another data silo. And whether you're in a public or private sector, data growth is just absolutely staggering. You don't have to go through acquisitions or reorganizations to just witness the organic data growth that's going on within your department or organization. I think my personal favorite, though, is you don't always own the data sources you're trying to interpret. Real story, I had someone come to me many years ago and gave me 100 megabytes of Excel that were in a zip file and asked me to run an analysis on it. And I think I had to have at least 3 one-hour conversations with that person before I could even start the data analysis. Why? Because I didn't have the context to what the data was even about. I needed that person's subject matter expertise in just to begin the data analysis process. And then finally, how the data is represented or stored may prevent us from using it the way that we want. And I think the classic example here is structured versus unstructured data. Structured data being things that are nights and rows and columns and type of databases, and unstructured being my PDF documents and my Word documents that live in my content management systems. I typically don't have a common tool or a common way to think about data that crosses those two data silos. So if those are kind of like, I don't know, the data problems or the data silo problems deep down at my data layer, these is typically how they may manifest themselves when I'm talking to my colleagues or talking to my constituents. And you've had some type of these types of conversations with people that you've worked with over time. But I think we can all kind of relate to the general use case or a general problem statement is, hey, I go to a website, I'm trying to find something, and I can't find the information I'm looking for. So what do? I open up a support ticket, I pick up the phone, I send an email, something else. Generally speaking, the root cause of that issue of you not being able to find what you're looking for is because the way the information is presented might be different than how I'm looking for it. And so basically you have a data silo between how people are looking for information and how it's being represented on the website or the application that it's providing. And there are real hard numbers behind the way that data is structured or the way that it's poorly structured. Data silos and other type of data problems, according to Gartner, could easily cost an organization up to $13 million per year. So there are really some, I'll say, serious costs associated with not kind of getting the data right. Now, to understand this problem at the next layer, we kind of have to kind of peel the onion back an additional layer to really kind of figure out, well, what's going on here? And this kind of gets into the study of semantics, which is the study of language and its meaning. And there's 2 fundamental things that are going on when we think about language and meaning. One is we have this concept of synonyms, so it's words that can basically be representative or identical to other words in their meaning. That one's fairly straightforward. The other one's not so straightforward, is we have this challenge in English language, and this will also relate to everything that's going down at the data layer. We have this challenge of the ambiguity of what's being said. So for example, I use this example with clients all the time. If I say, hey, if I went to the store today and bought an apple, there's not enough context there for whether I'm talking about potentially a piece of fruit. I'm probably not talking about a person, hopefully, or if I'm talking about a piece of laptop computer because I just bought a new Apple laptop. There isn't enough concept there. And this is what really causes the ambiguity and the challenge that we have. And actually is one of the fundamental problems of the root of data silos. I have a way that we talk about things and its possible meanings. Now, you may be thinking to yourself, hey, this is a fairly esoteric topic. Semantics really doesn't affect my everyday life. And I want to kind of dispel that myth because I do think we have semantic challenges every day. So I found this short video. It's actually less than a minute in length, but I think it highlights kind of the semantic challenges, well, at least that I personally go through. So why don't we take a quick look at this video and we'll pick it up from there.
Hello, husband helpline. Hi, I need some help interpreting something my wife said. I can transfer you to one of our translators on staff. Thank you so much. Husband helpline, wife translator division. Hi, I need help with a translation. Of course, what did she say? Well, I asked her if I could hang out with friends tonight, and she said, do what you want. Alright, and was this via text or in person? Text. So our system is bringing up a couple of possibilities. It seems like there's a 55% chance that do what you want, in this context, actually means you better not even think about hanging out with friends. 55%? Meanwhile, there's only a 15% chance that it actually means do what you want. There's also a 30% chance that she actually secretly wants you to go so she can have the night to herself. Okay, so what do I do? Well, it's a 45% chance you should go, a 55% chance you shouldn't go, and a 100% chance that you make the wrong choice.
All right, so we've identified that there are definitely some semantic challenges, but if we can figure out how to address them with our data, then we might be able to start breaking down these data silos. So let's get into it. Are we going to use semantics to break down the data silos within my organization? So one of the first things that we need to realize is that vocabulary changes over time. It's not that I start taking a semantic approach to my data and I stop taking a semantic approach to my data. It's something I always have to be thinking about. And this is just an example of that. So again, just an example from Google's Ngram viewer. This is the usage of the term lunar roving vehicle and moon buggy over time. So during the Apollo missions, that thing that drove around on the surface of the moon, the official term from NASA was a lunar roving vehicle. However, that term got replaced over time with what we normally think about as the moon buggy. So we just need to acknowledge that vocabulary is going to change over time, and that when we're taking a semantic approach to our data, it is an ongoing exercise. So that's the first step in taking a semantic approach is one, we have to identify our vocabulary space, and we have to be able to capture all the information in a way that makes specific sense to our organization. Now, a lot of people think, oh, that sounds like a really complicated exercise. What you have to think about, or the way that you need to approach that, is really leveraging the various subject matter experts you have within your organization. Don't try to necessarily do this yourself. Take advantage of all the expertise you have within your organization in order to do that. The other thing you have to remember too is don't reinvent the wheel. There's probably a lot of existing open source vocabularies that are out there, and you can use those as a good starting point or integrate them with your own vocabulary space that you're trying to model. And then finally, you need to represent all these vocabularies in a standard format. That will typically be in the format of a taxonomy or ontology, but it could be something as simple as just a controlled vocabulary. Okay, the next step in the process is once I've kind of defined my vocabulary and terminology space, I need to define the metadata or the attributes that I want to store with my data regardless of system or silo. So this is where I'm now starting to be able to break down the silos of my data stores. So for any particular piece of data, what are the things that I'm interested about that data? It might be something like author, date, title, topic, security level. That's the metadata or the attributes that I want to store with that data. And then the third step is I need to be able to associate those two together. So I need to be able to classify, or sometimes referred to as tagging, data to its appropriate metadata. So basically the data and its attributes, and storing them together as a single thing. It's not just enough to ingest 30 gigabytes of data. What we want to be thinking about is ingesting 30 gigabytes of data and the meaning behind that data at the same time. So we don't want to wait till there's a requirement or a mission need. We want to be able to start associating the metadata and the data together at the time of ingest. So I'm going to go through a little bit of each of these in a little bit more detail, just so that we all understand it. And then we'll talking about some particular use cases. So what's a taxonomy? It's really just a way to group content into logical categories. And I think a really great example of this is a grocery store. Next time you walk into a grocery store, you're really just walking into a taxonomy. Things are organized by produce, by meat department, by dry goods, by seasonal items. That is basically a taxonomy. It is a way for us to organize information together so it's just more easily searchable, easily findable, and that we have a common way of sorting things together when we receive them. Okay, the next step in the process would be associating metadata to a new piece of item. So if we're going to use the grocery store analogy, let's say we just had a new shipment of apples come onto the loading dock and we need to put them in the right department. All right, well, before we do that, we need to know some things about those apples, right? Where did they come from? What's the expiration date? Maybe other things that I want to know about that before I go and store them on the shelf. Now, when I make that connection between the apple and its attributes, I've now created a semantical interpretation of that piece of data. So I basically have combined the data and its associated metadata together that now allows me to fully understand it and do something with it that makes sense for the particular organization I've set up. In this case, put it on the correct shelf within the produce department of my grocery store. And then finally, what is content tagging? Content tagging is basically using that taxonomy to provide consistent metadata. That's really the key, consistent metadata to all those things coming into my store. So whether I am authoring new content, whether I'm ingesting new data, and I'm basically uploading to my website from a publishing perspective, or I'm just putting data in my data lake, the important thing is I've always got to apply consistent metadata tags based on the taxonomy that I've defined for my organization. So if I start doing that, what you're going to find is those isolated and independent data silos within your organization that aren't really well connected to each other or not connected at all, they will be connected through a semantical interpretation, and this will be kind of the starts of actually putting together a knowledge graph for your organization as well too. So now let's say I have multiple content document repositories, and Stephen Reed has authored documents in each of those repositories. I can now do things like, hey, I want to see all documents that Stephen Reed wrote, regardless of what repository that document is in. Now I can start linking those data items together. Do your data silos still exist? Yeah, they still exist down at the data layer, but now I have a semantic way to actually link them, and I can do much more interesting things from a knowledge discovery now that I have a semantic understanding of my data sources. So with that, we're going to look at a couple different public sector use cases. And as I mentioned earlier, each use case is going to look at using semantics with a particular application type. So we're going to look at business intelligence, content management systems, search engines, and case management systems as well. And each use case is going to be it's kind of like I'm build on the last one, and each one's going to be a little bit more complicated than the last. So let's get into this and start looking at how we can use semantics to break down data silos. Okay, so our first use case is we have a state and they need to report on how much Medicaid funds were distributed for thoracic surgery, which is a defined NUC category. Now, if you're not a healthcare specialist, don't worry about it. Really, all you have to know the difference between NUC and CPT codes is NUC is basically an insurance/claims code, and CPT is more like the medical procedure. So CPTs are defined by the American Medical Association. So basically, we kind of have data that's stored in CPT, but we need to report on it based on its NUC category. So how would we do this? Well, if we have our data on the left-hand side that's stored with CPT, actually what we can do is just interrogate the taxonomy. We don't necessarily have to do any tagging here. We can just interrogate the taxonomy and say, hey, what is the CPT code? And how is that associated with thoracic surgery? Now, in this use case, it's interesting because we're actually doing kind of like a code crosswalk, because there isn't necessarily a direct relationship between the CPT code and the NUC category. We actually have to take this intermediary step to an HSN code in order to make that linkage. And that's actually through the common concept of a cardiovascular procedure. So that's actually how we're doing it. We're making a linkage, actually 2 steps from one code set to another in order to be able to provide this report back in the way that the question is being asked. So that's just one example of how we can just use a base taxonomy to understand from one code set to another. Our next use case is around content management. Now, in this use case, we have a transportation agency that's receiving accident reports nationally. However, the reports are in a somewhat common format, but because they're being written by different people, different jargons being used, different abbreviations are being used. So it makes it difficult to put those reports into a content management system for more search and retrieval. So in this use case, we're going to come up with the example of we've got some reporters that are actually listing the make and manufacturer of the vehicle, while other reporters are just specifying the vehicle identification or VIN number. So how do we solve this problem? We've got basically different data different data vocabularies, but we're trying to have a unified content management experience. In this case, what we do is we take all those vehicle accident reports, we'd interpret them. And again, this is where kind of the uses of natural language processing helps as well too. And we'd be able to identify through the taxonomy the manufacturer and model of the vehicles mentioned in the vehicle accident reports. If they're directly referenced, great, we'll be able to pick that up and we'll be able to tag them as such. But because we can also model VIN prefixes, we know certain prefixes that are associated with certain manufacturer and models of cars. So we can basically do that through our taxonomy and apply the appropriate tags. So now I can have an analyst go to their content management system, say, hey, I want to see all the accidents from, that involved a Ford Explorer. They can go type this into their content management system. They can readily get these accident reports back, even though the string Ford Explorer potentially exists nowhere in the vehicle accident report. Okay, next use case. So now search. So search and content management actually have some similar problems. And the fundamental problem typically with all search systems, typically with all content management systems, is lots and lots of data and no one can find anything, right? So you're probably very familiar with that. When we have documents, though, that are very lengthy, that even gets even more compounded. So it's very difficult to find the information I want if it's like 50 pages into a particular report. So I have to have a really good way of being able to search through that information if from a user experience perspective. So in this case, we have a healthcare agency. They're receiving somewhat standardized reports, but these reports are very lengthy, highly unstructured. So it's very difficult to find information that I'm looking for in these reports. So we're going to take the exact same process here. What we're going to do is we're going to take those industry reports. We're going to use some natural language processing, apply the appropriate tags to them. And then because we've done that, we will be able to give the users additional tools to explore that information. So you're probably familiar with these types of GUI widgets that you would see on like a search or content management system, like the search as you type feature. But the reason that any of those tools works, or at least the reason that any of those tools work well, is because the input data, the data that I'm ingesting, has been properly tagged and it identifies as being relevant to things that I'm looking for. So whether I'm going through the content in like a tree/faceted search or through a search as you type, or even just visually, the only reason that those work well is because I properly have identified the content at ingest. And then our last use case that we're going to talk about is case management. So in this use case, we have a government agency. They're receiving social worker notes, and they need to be routed to the proper department. The real challenge here is the case notes are very inconsistently constructed. There's really no format to how they're put together. So because of that, each case note basically needs to be reviewed manually and routed to the correct department or departments based on things that are called out in that report. So this can be a very tedious exercise. It can be very error prone, and it can result in delays to serving my constituents. So what do I do here? Well, again, when you start thinking about using natural language processing and taxonomies, I can basically read those case notes, and that information can be surfaced really in any order. I don't have to have things structured at all, because if I'm interpreting them from a semantical perspective, I can apply the appropriate tags based on what I'm seeing inside those detailed case notes. So I've kind of broken down the data silo between how the case notes are written and representative and how they need need to be presented to my system so they can actually take action on them. So for example, if there's something in the detailed case notes that alludes to child abuse or alludes to someone having problems finding appropriate shelter, then maybe I can use that as information to route it either Child Protective Services, or maybe if there's multiple issues involved in those detailed case notes, maybe I would route that to multiple agencies to take action on. So that is the last use case I wanted to talk about. I'm going to turn things over now to my colleague, Steve Ingram, and he's going to provide a demonstration of how we can use semantics in action. Steve, over to you.
Cool. So thank you, Stephen. My name is Steve Ingram, and I'll be taking you through a quick demonstration of how Progress Semaphore can optimize case management. But first, I guess we should give you an introduction to Progress Semaphore. Semaphore is Progress's semantic AI platform. It was originally launched by SmartLogic in 2006 and has been a market leader ever since. Semaphore is all about leveraging unstructured content in your agency to improve efficiencies and make better decisions. It does this using a combination of natural language processing and knowledge models, and codifying institutional knowledge into models, which sometimes referred to as taxonomies, ontologies, control vocabularies, or glossaries, allows data to be reused across all your departments. And there are three main components to Semaphore. There is the modeling, the curation, the management of this institutional knowledge in a collaborative manner. There's the use of these knowledge models to provide a rich layer of metadata over unstructured content. And lastly, there is the ability to integrate this knowledge into your business processes, so that every department, every member of your various teams is aware of what the terms may mean, what is the meaning of terms, and therefore what is the meaning of the data. Now, what does that give you in practice? So using Semaphore, you can turn free-form text, on the left we have an accident report, into meaningful data that can be processed by downstream applications, or even to make life easier for us humans. And so in this illustration, Semaphore is extracting key items from the text and making them available in a unified manner for further processing. And this creates a rich layer of consistent metadata, normalizing both the data and the terminology used in that data so that multiple teams can benefit. And how can we apply this to case management? This workflow is typical of many case management challenges. Documents on the left are submitted by subject matter experts into a repository where they'll be actioned by a wider community or audience. Now, by injecting Semaphore into the report submission process, we can ensure that the documents are enriched with additional metadata. And this metadata will perform a number of roles. It will normalize the terminology used into a standard vocabulary, and therefore it will improve access, discoverability, and indeed routing, and flag key items for particular attention. And this enrichment will take into account not only sort of standard subject definitions, but moreover, it can leverage the input of the subject matter experts themselves, ultimately creating a no-code environment whereby the process can be optimized without requiring IT intervention. So I'd like to illustrate this with a demonstration of Semaphore within case management. And in the scenario I'm about to show you, which is implementing exactly the same workflow you saw on the previous slide, Semaphore is processing visit reports from caseworkers. And these reports are enriched from a general health taxonomy and also by definitions maintained by the caseworkers themselves. And before I go into the demo, though, I'd like just to explain what you're going to be seeing. So to demonstrate Semaphore, I'll be using a component called Document Analyzer, which is pictured on the right. This is something that you can use to see how the Semaphore enrichment process is working. You can also use this to understand more about the text of the documents you're processing themselves. Now, in a production system, Semaphore will be automatically processing submitted documents. And enrichment does not require manual intervention, but I'm just going to be showing you using this tool for the purposes of this demonstration. Now, sometimes Semaphore is assisting manual classification when we're providing suggested terms, but that's not being implemented in this implementation. And then on the left, we have what's called the Knowledge Model Manager, and this is the collaborative tool used for managing knowledge models. Right, so let's actually get into the demonstration itself. Let me just switch screens. And here we are. So this is Semaphore, this is running actually on my one of our cloud environments. And these are all three components of Semaphore. So on the green panel, we have the modeling piece. In the yellow panel, we have the integration piece, which allows searching and browsing of the definitions within the knowledge models. And in the blue, we have the document analyzer, which is actually showing you the enrichment process. So let's look at our first scenario. So we said early on that caseworkers are often pushed for time. So how can Semaphore help with that? Well, we can help with that by automatically populating metadata. So what we have is, these are 3 caseworker reports. The file name isn't really helping us. And rather than force the caseworker to sit down and actually come up with, rich metadata and rich descriptions, let's make Semaphore do that job. So we're going to drop into our server, and we're going to drop in one of our case reports. So these are literally just text files, but they do contain relevant information. So on the left, we have the text file that's been retrieved, the case report, and on the right, we have the metadata items that Semaphore is going to be adding to this document. So let's look just in a simple case. Let's just look at so the first thing we've actually identified it as a case report. So we've done what was called a fingerprinting, and then we're returning metadata items. So we're identifying from the text who the caseworker was, who the client is, who the subject is, subject age, so all the sort of information that you might want to do if you want to process or slice and dice, a couple of thousand reports. You want to see all the reports submitted by the caseworker, and they could be sitting in a large file. We've identified the caseworker. You can select Alex Martinez, and this document will be returned in the set of case notes. And again, this is all being done from the free text field that just was at the front of this document. So we've told Semaphore how to read that. It's not magic. We've told Semaphore how to read that, how to break it down into its constituent parts, and then that is now available as metadata to help with discovery, help with slicing and dicing and sorting these records. So our second challenge was caseworkers use shorthand and jargon. So how does Semaphore help with that? Now that's where the use of the knowledge models really starts to come in, because we can classify this concept document. We can actually indicate with this document the metadata, the topics that are discussed in this document, and that can be used for discoverability, or more importantly for routing. So let's look at some of these. I'm terribly sorry, I should have mentioned it. So these items are all metadata properties that Semaphore has identified to be added to the document. They're not being read from the binary file because the file is just text, but these are all coming from the text that we are returning. So we're able to see, we know how to find the caseworker reference, and we're returning the name. We know how to find the subject, etc. So these things on the right-hand side are all metadata properties. So these are being read out of the document. But what we can also do is classify it against a care taxonomy, for example, and any of the taxonomies that are configured in the system. So let's have a look at those results. So let's unpick the document type, and then let's select the items from the care taxonomy. And so everything from a taxonomy has a category. So conditions and diseases, long-term care and support, staying healthy, the topics in the document. There'll be the topic itself, and then there'll be a confidence score. Now, we're not showing anything below a threshold of about 0.48, that's standard. So these are all the things that we think are important about this document. In fact, if we were to sort it by score, you'll see that the ones at the top are, the most important aspect of this document, and then going down to the ones that are least important. We can see right at the top, there's concerns here around bruising. We've got psychological therapy, we've got anger management. So we can very quickly get a handle on we need to do something particularly carefully. We need to handle this document quite carefully. But also, if you wanted to do longer term research into child growth and development, for example, now there's nothing in the document metadata, there's nothing in the title of the document that tells you that this document might be relevant to child growth and development, but it's been categorized with that And so we can then, this document would now again be something you wanted to say, show me everything relating to growth and development. Then we can make certain that this document is returned in that set. And importantly, that frame of reference, that standard term, child growth development, is the accepted term, and so people can always, we're marking it up with a normalized and consistent there of metadata. But then the third aspect is how do we use this information? And so we can actually take some of the classification. We can say, let's look for flags. So we've got the taxonomy saying this is about bruising, but it's not telling us what about bruising it's being discussed. And that's where we can combine our natural language processing engine with our stored knowledge, with our knowledge models, our taxonomies, ontologies, etc. And we can start to actually effectively pre-read this report. So let me look now at, let's look at comments and concerns. So what we're doing here is we are identifying things that might be worth providing more attention to, because we're looking at how things are expressed in the content. So we've got some concerns here. So that's the first one. Well, we found a sentence here which is discussing visible bruises. We've got this one here, which is discussing these, again, red flags: avoiding eye contact and unusually quiet. So rather than force somebody to look through these records, we can actually pre-read it, surface it as metadata, and then if you wanted to say, "Oh, show me all cases relating to a client who is a subject who is avoiding eye contact and unusually quiet," and then we can see all the data associated with that, and maybe we can use that for reporting, feed it onto a machine learning algorithm, how we want to do it, but we've pre-read the document for you. And we can also sort of be quite clever about it, because if we actually now look at, let me get this one right, I think it's the third one. No, it's not the third one, is it? Oh, that was the fourth one. There we go. So we can also look for good things as well. So we have a sort of set of definitions for concerns to look for, and a set of concerns, it's definitions which indicate, success and positivity. But also we could look for the negative of that. So if we just looked for the word happiness or cheerful demeanor or something like that, then we would show that as a positive flag. But actually what we're saying is a significant change. So we can look for false positives. We can look for false negatives as well. So like, for example, let's go back to one of my other reports. Let's drop this one in. Again, all we've got now is a reference number. That's not telling us much. So we submit it to Semaphore. Semaphore will do exactly what you saw before. It will sorry, I set off disabled the options. So we're doing the same thing you saw before. It's fingerprinting it. It's returning the case information. It's doing the classification against the taxonomy. As you can see, there's not a lot of concern here because this is a positive story. But if we look at this one now, safety hazards is one of our concerns, but what the sentence is actually saying is there are no safety hazards. So we can, instead of rephrasing this as a concern, we can rephrase it as a comment and say, it's good, no safety hazards evidence. So we can look for we can look for red flags, we can look for green flags, we can look for false positives, we can look for false negatives, and we can treat them accordingly. And this is all done in a no-code environment, and it's all managed by the subject matter experts themselves, because all they need to do is update the knowledge model with the different definitions, flags they want to look for, alternative labels, capture all the knowledge that they already have. And so what Semaphore will do is Semaphore will read one of these reports in exactly the same way as a human agent would, but we're doing it all for you, doing it a lot quicker, and we're all doing it automatically. Now, before I just finish, I just want to explain what we mean by a knowledge model. So this is the CARE knowledge model that was used for that classification. And what a knowledge model is a set of concepts which are sort of meaningful to you, terms that are meaningful to your agency, your team, your department, and then definitions for exactly what is the meaning of those terms. I managed getting myself confused there, but if we look at this example, we have this is our CARE taxonomy. We have physiotherapy as a concept. It's a thing. It's actually a treatment. And we can see where it sits within a hierarchy of treatments. On the left-hand side is what we call the concept schemes. And then on the, we may have alternative terms for physiotherapy. So physio is an obvious shorthand. And then we have the relationship. So what is this related to? So we have what can be treated by it, who delivers it, what part of the body it affects. And this can be absolutely as rich as you like. And so Semaphore provides a very simple, very straightforward interface for managing these definitions. And then we can actually then start to use these to classify documents. And importantly, when we do this document classifying, we're not necessarily looking just for keywords to appear in the document, but we can look for other terms as well. So a term, if we want to classify a document as being about education, the word education actually doesn't have to appear anywhere in those documents, but if it describes all the terms that relate to education, then we will classify it as such. And that is what we mean by semantic classification. So I hope that has helped explain how Semaphore can work in a case management situation. Over to Stephen.
Stephen, thank you for that demonstration. So just kind of summarize, we just wanted to kind of recap the benefits of taking a semantic approach to your data. So obviously we can start connecting disparate data sources through a unified vocabulary that we've captured probably in either a taxonomy or ontology format. We can now start translating mission concepts into the data layer. So again, we typically talk in a different language than the data is necessarily stored. But if we have a unified vocabulary, if we have a way to connect that information, now we can start linking that information together. We can also speed the analysis of data, because if we start tagging it at ingest, and this is a very important step, if you start tagging it at ingest, then the meaning of that data is stored with the data itself, and it's basically available to upstream applications and systems pretty much at time of ingest, and doesn't necessarily have to go through any transformation functions. We can reduce the need to duplicate that information, because now we've got to basically, we can leave predominantly most of our data inside of the system of record, and we just apply the metadata information to it, and we don't create another data silo through an ETL. We also get to allow to treat our structured and unstructured data similarly. So the way that we kind of look at databases and the way that we look at content management systems, we can now start merging those data silos together, because we now have this metadata infrastructure supporting both of those. And then finally, we can start knocking down those data silos and preparing you for mission success. So with that, we'll take any questions that we have. Thank you for your time today. Hope you found something useful out of it, and we'll do some Q&A now.